I'm going to work a pair of examples in which I start with a basic function formula, f of x equals x squared, and I apply a series of 4 different transformations to get a more complicated formula. And I'm going to start with this sequence right here. Shifting to the left 2, reflecting about the y-axis. Now that's not the upside down kind of reflection, that's side to side. Then I reflect about the x-axis, and then I take that function and I shift it up 3 units. Now shifting to the left 2 means taking 2 units away from every x-coordinate of every point in the graph. So imagine that 0, 0 becomes negative 2, 0 if it were in your graph. Now to make that show in the formula, you have to remove the letter x from your formula. So I just deleted the letter x, and in its place I put empty parentheses. Now inside of that space I put x plus 2 to show that I'm shifting to the left. Next I want to reflect across the y-axis, and so I'm going to take this formula and change it again. I want to follow the same procedure because reflecting about the y-axis means that you're taking positive x's and making them negative, you're taking negative x's and making them positive, and so I'm going to delete the letter x, leave empty parentheses in its place, and in that empty space I put the negative. Now at this time I'm going to try to simplify because it makes my later work easier, so I have negative x plus 2 quantity squared. Now I have to take f sub 2 and reflect that about the x-axis. I need to flip this thing upside down. And that means taking positive y's, making them negative, taking negative y's, making them positive. And whenever you're doing a transformation that involves the y-coordinates, you have to put giant brackets around your entire formula, no matter how complicated it is. So I took this, put brackets around it, and then I put a minus sign in front of that. That's how I know I'm getting the transformation right. And I can simplify this later if I want to. I'm ready for the 4th step, which is shifting up 3 units. And again, shifting up 3 units means taking all the y's and increasing them by 3, which means taking this formula, putting brackets around that, and then putting the plus 3 outside of there, simplifying if we so desire. So now this problem is complete. Here's the second exercise that I want to try. I'm going to start with the same function formula, f of x equals x squared, and I'm going to apply 4 transformations again, but you notice that the order is different. Reflect about the y-axis, shift left 2, then shift up 3, then reflect about the x-axis. The order is completely scrambled up. So to reflect about the y-axis, I followed the same procedure as in the last problem. Delete the letter x, leave the empty parentheses, and in that space you write that minus x. Unlike a lot of problems here, I have an opportunity to simplify. You know how negative 3 times negative 3 is actually positive 9? So that minus doesn't really change anything. I can simplify this to be just x squared. Next I want to shift to the left 2. I take this formula right here, delete the letter x, put empty parentheses down, and inside of that space I put x plus 2. So I have x plus 2 quantity squared. Next I want to shift up 3, and so I'm just going to take the entire formula from f sub 2, put brackets around it, and then tack that plus 3 on at the end, because shifting up 3 means altering the y's, which means you have to follow this second procedure. Here's where it gets interesting. I simplify this formula, and I know I want to take this thing and reflect it across the x-axis. I have to take this entire formula and put brackets around it, then put the minus in front of that. Now when you simplify this, you get negative x plus 2 quantity squared minus 3. That minus sign has to be distributed to the 2 terms. So this problem is complete, but you may be surprised that when you reflect about the x-axis, you can't just throw a negative sign out in front of whatever you have. You need to be certain to get those brackets involved so that you remember to distribute the negative. It's really important that you get that algebra just so. And also, I want to point out that this is a very different formula from the first problem, which means that scrambling the order of the transformations completely altered my answer.